Welcome to the Node Guardians YouTube channel, where we discuss all things blockchain, smart contract programming, decentralized web, and cryptography. I'm your host, Sam, and I'm today with Lumi, who's an independent researcher in the Web3 space. And we welcome Sergey Gorbunov from Axelar today. Axelar, which is a cross-chain interoperability platform that enables communications between various blockchain ecosystems, let's say. It's always a pleasure to welcome you on the show. I reckon that it's the 5th time that we actually get to do some kind of interview podcast. So very excited to have all the updates about the Axelar stack, what has been changing. But before we dive into all of this, it would be lovely to know how you're doing and how you actually ended up working on Axelar.
Yeah, no, great to chat again, and thanks for having me. I'm doing great, so hopefully, everyone is doing well. Frankly, I think it's been a rough year, and I guess last few months for crypto, right? So I think whoever is going through it, I think, shout out to everybody that sort of continue to build in the space, right, and continue to build in the bear winter. So I think it's, an important mission that we're going through. For me and Axelar, how we started by thinking about cross-chain problems after launching the Algorand protocol with my co-founder Yorgos. And so after launching it and taking it to the market, we wanted to connect it with other blockchains, and there was no really kind of protocol that we could use or a solution that we could rely on. And so we started Axelar to tackle that, so that it's as frictionless as possible to connect new ecosystems, new consensus layers, new smart contract layers. I think it's pretty vital that we know how to do this well as the ecosystem continues to grow and continues to become more, fragmented into different layers of the stack. We still need to unify everything together for the developers and users. So kind of excited to continue working on this problem.
Amazing. And could you give us a high-level overview of the Axelar architecture? I guess it's based on the Cosmos SDK. You've built a Cosmos module with some intricacies that communicates with the underlying layer. Would be really cool to have an architectural overview of the Axelar network.
Yeah, on the high level, kind of Axelar network is a decentralized network powered by proof-of-stake consensus that's responsible for processing cross-chain messages, right? So the idea is that on different chains that are being connected through the stack, we have this notion of what we call as a gateway, right? A gateway you can think of as a router, right? It's a smart contract that lives on every chain, and application developers can read and write in messages to those gateways/routers, right? And then underneath all of this is the Axelar network protocol that's responsible for taking the messages from one of these kind of gateway/router, validating them using one of the variety of approaches. So we support like IBC, and we support other consensus mechanisms to validate messages depending on the chain, finalize them, and then the validators decide what needs to happen to that message subsequently, right? So as an example, what chain it needs to go to, or maybe it needs to be actually translated in the process. If it's a message from like an Ethereum ecosystem to a Cosmos ecosystem, there is actual kind of a message translation that has to happen. So validators do all that logic, and then they push the messages to the outgoing routers, gateways, where they get processed and subsumed by the applications, right? So from an application perspective, it's actually a very, very simple API. There's 3 parameters you have to specify on the to specify the destination contract, destination chain you're calling, and all the complexity of message routing, parsing, translation, finalization, relaying is handled by the Axelar stack underneath the hood, right? As you said, Sam, stack is powered by kind of Tendermint and Cosmos SDK, and then we optimized it or we customized it for the problem of interoperability. So it has pretty nice properties. I mean, I can go kind of into details on those as well.
And so, yeah, the overall solution is non-canonical. So you connect, it's a non-canonical bridge, let's call it this way. You connect different blockchains together, let's say that. And you're actually the canonical bridge of osmosis when it comes to the whole inter-chain ecosystem. And speaking of the design of Axelar, so far, I think it's been settling nearly $2 billion of volume. There hasn't been any security incident yet, and we wish that it continues this way. So when I've been going through the latest blog posts on the Axelar website, you mentioned that you have a certain process, you have some good practices and engineering, let's say, methods to ensure that, to basically reduce the risk of something bad happening. You correct me if I'm wrong, but in Axelar, you still have liquidity that is locked up in contracts, right?
Depends on the application, right? So kind of bridging as an application built on top of Axelar does lock liquidity. There are other applications that do not lock liquidity and transfer like general messages only.
Yeah, and so you can have, for instance, someone that is sending some kind of predicate and intent that he's willing to change token X for token Y, and some market makers or some operators can pick up the order and settle it on the target chain, right?
We don't work with kind of operators or market makers, right? This is up to the applications themselves to decide like what happens with what their messages consist of, right, and how they get settled on the destination chain. So Axelar itself is a general kind of a transaction processing network, right? So it's kind of in the same way as Ethereum is completely sort of agnostic to what the messages are, right? They would just process them and like sequence them. Axelar in the same way is kind of agnostic to what the messages are. You can have, of course, tokens being included in those messages. You can have, NFTs. You can have contract calls or anything else kind of generic from it.
Okay, very cool. And yeah, we hear a lot about building cross-chain and composable applications, et cetera, et cetera. And given the events that we've had over the last like 2 years, probably like nearly $5 billion or $6 billion have been exploited through all sorts of bridge-related incidents. It became quite a tricky topic to announce that you're building cross-chain. Yet there's still a need for that. There's a strong demand for that. And as time goes, I guess systems are offering better guarantees to build this way. So lately, you've been introducing the AVM, which is a Cosmosm module that is built on top of Axelar's like essential primitives, let's say. And you label it as the Kubernetes, the orchestration framework for the cross-chain world, let's say. So could you give us like some key points, list us what are the key features that this new virtual machine enables the developer to do? Like, I don't know, deploying or updating multiple contracts at once. What could be the cool things that we could foresee on top of this?
Yeah, so kind of the virtual machine itself is powered by a hybrid, right, of kind of Cosmosm module plus like the on-chain Axelar network kind of interoperability gadgets, what we'll call them, right? And so there's like a hybrid of them that needs to happen to make it work. It is a generic kind of a Turing complete environment, right? So meaning that, imagination is your limit at the end of the day. That being said, I think programmability at the interoperability layer has pretty interesting properties when it comes to the Axelar network stack. So on top of it, we're going to work on some initial services. One of them is kind of what we call is interchain amplifier, right? So the idea is that if you're building a chain and you want to connect it with other ecosystems, how do you do that? Right? What is a programmable way, and what is a set of like templates or code that you can instantiate to connect your chain with dozens or hundreds of other environments, right? And so kind of having a programmability on Axelar through the amplifier is the way for developers to do that. So if you're innovating on a layer 1 or layer 2, maybe you customize consensus, maybe you customize like your smart contract environment, whatever that is, making a connection from that layer 1 to other ecosystems is expensive process, right? Like, depending on the protocol you use, like if you're using like Light Client or ZK or external validation, but it's a process anywhere from 6 months to years of work, right? And so you want to make sure that you get the best outcome by building those connections. And the best outcome usually is when you get kind of amplification effect of your work, right? And so by having programmability on Axelar, this is what you get, is that by instantiating one connection, by enabling with the Axelar stack, you get access to all the other, dozens or hundreds of ecosystems down the line at the end of the day. So at the cost of, 4 months or 6 months or 1 year of work, you just get access to an existing ecosystem as opposed to one-off kind of a bridge connection, right? Which is always pairwise, and then you have to repeat the work over and over again. So this is one product that we're launching, on the virtual machine. The second product we're building on top of the Axelar virtual machine is the Interchain Maestro, right? And the idea is that as we speak with a lot of developers that are building in the multi-chain environments, they tell us that they spend most of their time actually thinking how to build, right? So they're thinking about, how do I deploy my contracts? How do I manage my upgrade processes? How do I manage my governance processes? What if I want to go to more chains? Like, how do I deploy there, and so on and so forth. So it's a lot of work that prevents developers from building applications that would span, the whole of Web3. And so the idea is, how can we make that whole experience simpler? And the way to do that is by effectively automating all the repetitive steps that developers take, in a set of contracts or templates, right? So the interchain maestro serve a product where you can say, okay, this is my bytecode. I want to take this bytecode. I want to ship it across 10 different chains, right, with one click, and have it all connected with the underlying like interoperability protocols, have it all been managed. If I have a new bytecode that I want to just replace, I can upload it once with one click, and it goes and kind of gets replacing my new bytecode. If I want to extend this to 10 other chains, it's again like one click deployment that you can manage, right? So projects like Kubernetes and traditional software environments allowed us to do that, which is like automating the deployment across fragmented software systems, right? But still act as one and being interconnected underneath the hood. And so that's what we're trying to do with the Maestro product. And again, like, this is thanks to the power of kind of having programmability at the interop layer itself, that you always have like a one hop management platform that sort of has the shortest path to any connected network that it's serving to provide like the best experience for these types of applications.
That's definitely a very cool application, the Maestro. And there's a lot of pain in this ecosystem with developers sort of having to re-engineer everything on their own, whether that's how to make cross-chain ecosystems possible within their dApp, or whether it's rebuilding dApps. And we've heard a few different bridging projects also talking about implementing virtual machines, and it seems like it's a direction that a lot of the bridges are going in. So I'm curious, sort of like what are the sort of theoretical applications, maybe third-party applications that have approached you guys that you find sort of very exciting use cases for this sort of cross-chain ecosystem of a dApp?
Yeah, I mean, kind of the way that I view this, if you take a step back, is that kind of interoperability, and programmability at the interoperability layer, it's not there for kind of serving you a DeFi or something else, right? Like, it's really there to build interoperability protocols, right? And kind of on the internet, if you look at interoperability protocols, it's really a stack that has been built, right? You have like TCP/IP, at the very bottom of it, at the top of it, you have various application layer protocols like HTTPS, protocols for sending, emails, and so on and so forth, right? And so what I think with the interoperability and kind of programmability at the networking layer allows you to do is to think, what are those kind of, to your point, applications, right, that could benefit from additional types of interoperability protocols, right? So to simplify like management orchestration. So I think like, naming protocols are one example, right? So there's a lot of questions like, how do I map, public key or contract address to a name? And that's something that, right now is like pretty fragmented across the ecosystems. Every chain has their own way of mapping those things. It's not usually portable. So if you go to another chain, you have to have another address, another name, and so on and so forth. So unifying all of that, so you can abstract like the wallet to application interactions, I think it's quite important, right? And this is an example of what I call interoperability protocol, right? In some sense, it's kind of a map A's to B in a human readable way that you want to make kind of a chain agnostic, right, and span everything. There are other protocols that we're chatting with. So for instance, if you're doing if you're sending transactions with value across chains, how could you speed those things up, right? How could you make it as efficient as possible to settle those transactions, maybe in like 5 seconds or 10 seconds, right? And so that again requires kind of a certain set of additional services to be built, right, to power those applications. So not necessarily relying on like full finality on the source chain, but those are very application specific, because you have to kind of think, what is like the risk reward factor, right? Like, do I have to wait for full finality, or for certain transactions I can kind of process them faster? So it's again like there's a we have this kind of a service that we're building. It's called like a GMP Express, and the idea is like for certain application classes, you can actually process their cross-chain requests, in like 5 or 10 seconds without having to wait for full finality, right? And then, so this is what I think we're kind of entering in the interoperability space, is like figuring out for specific applications, like how do you make their UX as simple as possible? How do you make their properties like as efficient as possible? And having programmability is like an enabler to all of this.
So speaking of abstracting the complexity of the interchain experience, let's call it this way. We also have like a bunch of different token standards across different chains, like ERC something, ICE something, ICS something. What is your roadmap, your agenda, and the methods, the systems that you can implement to standardize the standards or simplify the whole token swapping experience? Or no, I mean message passing experience, not token swapping.
Yeah. So I guess like two separate things, right? Like I do think that, when it comes to token standards or kind of standards of existing chains or ecosystems, I think they need to kind of evolve on their own, right? And we as Axelar always take the position that, the protocol and the interoperability network needs to be, as agnostic to it as possible and still be able to service it, right? So kind of as a requirement for the connection of Axelar, it was always the case that, the chain itself shouldn't have to make any changes, right? And so you'd be able to come in and deploy this gateway and then interact with all of the applications on it. So when it comes to like token standards, we actually have, there's like ERC20 if you look at it at the Ethereum ecosystem, and we actually put a proposal for this notion of like interchain token standard, right? And the idea is like it's basically your ERC20 on steroids, right? And like the steroids here allow you to send it cross chain, right? It's like extra one function call that you can use, to send it from one ecosystem to another. Everything else is like exactly the same, right? And so in that case, if your token standard, extends one interface, you'll be able to make it chain agnostic and deploy it across multiple chains, right? And send it back and forth with one another. Same thing with other, kind of standards for other assets. They should continue evolving and they should be standardized by those communities, right? And like we can help to think how to make them chain agnostic, right? But that's what developers gonna choose there. And then I think similar to other point, I think more generally, I do think that hopefully, over this year or so, there will be a wider effort to kind of standardize the message passing format, right? So whenever I think about interoperability, it's actually not a kind of a monolithic stack. It's really 3 layers you have to think about. You have to think about like message semantics, like how do you send the message from A to B, right? Think of it as like the header of your envelope, okay? Like it's very simple. It has a specific format. Everybody knows how to fill it in. And then underneath it, there's usually kind of the validation layer, how those messages are validated. And then below that, there's the transport layer, right? How do packets actually go from one network to another? And so while there's still a lot of work at the validation and the transport layer, and it's going to continue evolving, I do think like the message semantics layer, probably get standardized over the next kind of year or two. It's actually very simple, right? Like we just literally need to agree, like how do we specify, a zip code, right? Kind of stuff in the blockchain format, like how do you specify the recipient and the street and kind of and the address, and that's it. So I think that will get standardized over the next kind of year or two, while the validation and transport kind of a logic will continue evolving for probably forever, because that's how internet functions. Like those are not static properties, right? Like transport always gets better, it always gets more efficient, you always get kind of a more security, and the companies that continue innovating on that are the ones that are ahead of the game.
Yeah, I mean, we can only hope to see some TCP like protocol that finally overtakes and makes everyone, how to say that, agree and aligns everyone when it comes to the message formats. Let's put it this way. There's that new concept of one-time deposit addresses. Would be very curious to have you introduce that new feature.
Yeah, so the idea is that as we're building, right, one of the things we're trying to do is make sure that kind of traditional systems or even centralized systems are as interconnected with decentralized systems as possible, right? And so how do you do that today? Well, today you have to go to a centralized front end like Coinbase, right? And then you can do all of your functions there. If you want to interact with a decentralized exchange, you have to have a MetaMask, which is a smart wallet, right? And so the idea for deposit addresses was how can we generate the type of experience for the users to be able to go back and forth between these like centralized and decentralized systems with one kind of click experiences, right? And so the deposit addresses is you can think of it as a smart address that can be generated through the Axelar stack that allows a user to specify an action that they want to take without them having to have like a smart wallet. Okay, so basically, if you want to, as an example, let's say you have some USDC on Coinbase and you want to deposit it to, a pool on Osmosis with one click. All right, how do you do this? Kind of the traditional way would be you withdraw maybe USDC on Ethereum, right? Then you bridge it over, you like sign a transaction with MetaMask, then you execute another transaction on Osmosis to actually put it in the pool. So it's like 5 different UIs that you have to use just to get your funds available in a pool. We can do better, right? And so we can do better by generating these deposit addresses, what we call them, that have a program behind the scenes that executes all the user intents. Okay? So in this case, the user intent is, well, I want to route my funds from Ethereum to Osmosis and maybe deposit in a pool. Okay, so we can give them an address that looks no different than any other regular address, and they can just simply withdraw their funds from, from Coinbase to this address. But when the funds arrive there, a program will take action, and this program will route the assets to Osmosis, deposit them in pool. If they want to do something else, it can all be programmed into one step, right? And so the user never even has to think about Ethereum, never has to touch Ethereum, right? Never has to have, eat to actually pay for gas. And so everything is completely abstracted behind the scenes. I think it's actually one of the first practical real life use cases of like account abstraction types of paradigms, right? That I think a lot of the players are talking about or exploring. We actually didn't even know about the name when we were working on this, but this got shipped over a year ago by now. I think like a lot of people are rediscovering it now as the account abstraction kind of talks are picking up. But yeah, this is like abstracting completely away users' intent without them and have to have like smart wallet or anything else. One transaction that allows you to connect your centralized front ends with decentralized applications.
And how does the sort of like security properties work for that? So in a way, the wallet is essentially at this point managed by the validators of Axelar, I'm guessing, right? And so when a user send money to this account that then deposits it into Osmosis as an LP, what happens to the LP tokens? Do they sort of sit on that account? Do they go back to Coinbase? And then if they do sit on that account, how do I prove to this wallet that it was really me that owns this one-time address?
I mean, in this case, you would specify a program that says that the tokens, when they arrive in Osmosis pool, they actually belong to you, Mr. User, right? Like it does not belong to the Axelar validators or anything else underneath the hood. The Axelar validators will help you kind of validate the message on Ethereum, right? And like finalize it and then route it and then put it on Osmosis. But on Osmosis, kind of the message that will be executed is that these tokens, belong to this particular user, and this user puts them in the LP, and this is their address, right? So the address is already specified there. So the Axelar from that moment on is kind of removed from the picture. So the Axelar validators process the message, they finalize it, they execute it, but it's the user that has like the full control at the end of the day and decides what to do with the tokens.
And in regards to privacy, so the AVM is permissionless. Everyone can build on top of it. And because it's Turing complete and we can run an arbitrary computation on top of it, what would block us from having some kind of shielded pool on top of it? Like we could basically like deposit funds once in it and it will route it wherever we need it. And we would basically benefit from top-notch privacy. And yeah, Axelar could extend the range of its purposes. But what would you do if such service happened to exist on top of Axelar? Would we send? What is it? Something that you thought about? Is it something that is planned? I think that's a very exciting use case.
I mean, I 100% agree with you, right? Like, I think having some privacy on Axelar, could be quite nice. I think you can use it to have anonymity of transactions, one user send it from one chain to another and so on and so forth. That's exactly why we have like the virtual machine that's sort of Turing complete, right? That people can come in and like, have their own ideas and experiment and build and, leverage the existing kind of a stack to kind of have the the biggest return, right, on their kind of a engineering efforts sort of spent. We're actually working with a couple of different like privacy preserving chains as well to kind of help them export their privacy the way I think about it, right? So the idea is that if you have like a secret network or one of the other privacy preservers chains, if you want users to access your applications from other chains, how do you do that with one click, right? And so kind of have an Axelar in the middle allows you to export these privacy preserved functions, right, to other layer ones that might not have them at the native core, right? So if you want to, send a transaction, be able to have anonymity and privacy around it, you just perform a function call on your home native chain, right? That looks no different than the other, but it will have privacy preserving properties by the virtue of getting kind of routed to the privacy preserving chain that executed there, and you just kind of get a result maybe at the end of the day or not get a result. So I think it's actually a very, very interesting property of the interoperability stacks that's now come into place, is where you have different chains that have different properties, right? Some may be optimized for storage, some may be optimized for privacy, some optimized for fast finality, some optimized for, a unique kind of a virtual machine environment. Now they can all be composed with one another, right? And so you can build an application a lot more powerful where you can, pick and choose from across the ecosystem, as opposed to having to rely like on a single environment and like have all of your properties locked into one layer one. So I think this is really, really exciting, the space that we enter in with, where kind of your, Web3 computer is becoming extended.
Speaking of storage-specific ecosystems, I think that Filecoin is being added on the testnet in like 2-3 days. So yeah, we're getting there.
Yeah, getting there for sure. I think Filecoin, it's super exciting, right, to see it being interconnected.
Yeah, in regards to liveness, stability of the overall network, not security, but just it being available and cheap to work with. I remember back in the days on the Cosmos Hub, you had Prop 69 that was rejected because it would make the Cosmos Hub stray from its main relaying mission. Let's put it this way, hub and spoke kind of function. And some of the arguments that were given were that it would potentially increase the risk of liveness failures on the hub, and that might increase the cost of certain operations, etc. In regards to a potential surge of use on Axelar and more applications being deployed on top of the AVM, have you considered any approaches to ensure that there are no risks on the liveness side for the protocol, and that you can handle everyone's activity while remaining competitive in a landscape where sometimes you have bridges that do not offer such flexibility but offer a relatively cheap experience?
Yeah, no, great question. I mean, I think the reality have considered yes, right? Like, that we spend like days and nights kind of breathing and thinking about this thing. So the reality is that, I think no matter what, as the ecosystem scales, right, as you have more and more connections, you have to have kind of what I call is like horizontally scalable strategy, right? You have to be able to isolate components one from another. And kind of Axelar network from day one has been designed to do that, right? So as an example, kind of the validators today, they use an opt-in mechanism to opt in into the chains that they want to participate in, right? And as a validator, if you don't want to participate in some chains, you don't need to do that. And kind of the incentives are structured in a way that kind of the more work you do, the more you get rewards. So they're incentivizing people, but it's not a protocol requirement, let's say that, right? And so that's really the way kind of how we think about long term, to be able to horizontally scale the network by saying certain functions only need to be executed at certain layers of the stack, right? So some of them maybe need to be executed across maybe a smaller subset of validators. Some of them need to be executed across all of the validators. Some functions could actually be executed like completely off chain if you have like zero knowledge techniques or something, and then put back on the chain, right? You could even build like layer 2s on top of Axelar that says, okay, for certain chains that we'll want to process, we'll have like another kind of a validator set that finalizes these transactions and then routes it to the main Axelar hub. So in the same way as any stack, I think has to think about those things like we're thinking about those things on regular basis. But having the Axelar kind of a programmability, right, at the networking layer is what allows us to have those flexibilities, right? That's what allows us to have all these different instantiation models. And I think that's what kind of a big differentiator between it and other kind of interoperability protocols, right? That, are trying to connect A to B. There's not necessarily kind of a blockchain that powers things or processes things, and then you have to think about, where do I put those functions, right? Do I put it on this chain or that chain, right? Or do I run it completely off chain, and then I introduce like a centralization risk? So having Axelar with programmability allows us to modularize the network as much as possible as we scale.
So that's actually a fascinating topic, and I'm curious about what that looks like, that horizontal scaling, and slightly more specific, because for like when you go on a web page, you're literally making 200 requests out, 200 plus requests out, and these sort of intercommunication protocols handle substantially more traffic than it takes to make a transaction, right, or enter a web page. And in a way, blockchains are incredibly inefficient databases for being able to handle this. So at some point, Axelar fees could go theoretically above Ethereum's fees, assuming that you don't keep ramping up node size, right? So what does that, I'm curious to know what that kind of looks like, that horizontal scalability. Is that spinning up multiple Cosmos spokes and then making them communicate via IPC? Is that an L2 strategy, where the bottom layer is actually coordinating between the L2s what responsibility, or is that like a monolithic chain but with actual parallel transaction processing? So if this state is only used for X function, only the nodes running this can execute those transactions in parallel from this function, which whatever part of the API it might be. Like, what's the, like, I'm sure it's sort of early research still, it's not like super fleshed out, but I'm curious, like, what does that horizontal scaling look like?
Yeah, I mean, I guess a little bit of everything, right? Let me give you kind of a little bit more concretely what's sort of in the works right now. So one of the things in the works is essentially a way to instantiate connections to the Axelar through kind of a layer 2 instantiation, right? So the idea is that you can have an auxiliary or an additional sort of validator set, right? That maybe it runs like on top of Axelar, that's responsible for validating messages from one network or the other network, right? And it sort of isolated some of its functions, like to a different, validation technique. It settles it, and then when it settles it, it would post the messages on Axelar itself, and then those messages will get routed through the existing stack, right? So then you're not adding kind of a burden on the existing validators to, add more and more chains. Like at some point, they'll say, okay, we want to support this main, functions, but more and more chains can be added on sort of layer 2s, right? Instantiations of Axelar, and then, you can scale it from there. There is a world, I think, to your point, that I think I see where multiple instantiations of Axelar will be launched, right? And like responsible for either different traffic, but also some of the same traffic as well, to provide better security, right? So we actually wrote like a blog a couple of months ago. We talk about multi-path routing, right? So the idea is that if you go from, let's say Ethereum to another chain, you have one network that validates the traffic using validation technique. You could have another, either network or just another validation technique that validates the same traffic. And then at the destination application, you can say, well, I will authorize it if and only if both of these kind of networks or approaches have validated it, right? And they could have different implementations. They could have different validation logic, some based on like zero knowledge and another one based on like external validation using like validator sets. If both of them are authorized, only then I execute my transaction at the destination chain. But if it's maybe a low value transaction, then I actually don't care. Either one of them is good enough. But if it's a high value transaction, I would require like at least 2 independent methods, right, to validate it. So I could certainly see a world, where multiple kind of instances of the Axelar network sort of launched. They doing some independent, some mutually validation, and and then it kind of gets composed with one another. At the end of the day, like, if we are in a world of like hundreds of chains, right, you have to have topology that has like multiple sort of hubs in the middle, right? Like you can't have like one hub that connects sort of everything. You can't have everything in the peer-to-peer protocol. That's complete nonsense. Like you have quadratic number of connections, right? This is what like everyone else is doing. So you have to have hubs for just efficiency and like the cost mitigation. And you probably have like multiple hubs, right? And that's how, kind of air traffic control system is right? Like you have multiple hubs of connectivity. You have like Chicago, New York, London, right? Like Heathrow Airport and like so on and so forth. And then you have some small kind of a pairwise sort of connections within countries, within states, and so on and so forth, right? But everybody's looking for like the shortest path to go from A to B, and like you're gonna have to provide that, and you're gonna have to have protocols that do that.
You've basically said that based on the nature of the transaction and the volumes involved, you could have different parameters. In regards to latency, what would you what is the Axelar team currently working on to offer a better experience in that aspect?
Yeah, so when it comes to latency, we're kind of bound by the laws of physics of the source chain in some sense, right? So if the source chain has good latency, then can process it like instantly and deliver it to the final chain. If the source chain has long latency, like Ethereum, right, it's like 15 minutes on average, then we have to wait for it. But there are these application layer protocols that we can do to speed up things, right, without adding additional risks. So one of them is actually like GMP Express. So if you go to like axelarscan.io, like /GMP, you'll see under under the transaction that certain transactions, even from Ethereum, but yeah, so you see that there's certain transactions they actually execute like in 20 seconds or 30 seconds, right? So how is it done? It's done by looking at the application logic, right, and show you here. So if you look at the fourth transaction from the top, right, it's a transaction by the squid, goes from Polygon to Moonbeam, right? And so you can see that this transaction is actually executed in 20 seconds, fourth from the top, right? So
here.
Yep, that one, right? So you can see it's executed in 20 seconds, even though the real latency of Polygon would require it to be executed in something like 6 minutes, right? But you can see the one above it from Polygon to Moonbeam was actually executed in full 6 minutes. And that's because this is where the application deviation kind of comes in. It's kind of being tested right now, where for values that are small enough, right? I think it's like less than like $50 or something like that on the network. They can be executed right away at the destination by putting some capital up front, right? So if it's like a swap that needs to happen or a transfer plus swap that needs to happen from Polygon to Moonbeam, anybody can come in and say, oh, I'm gonna put this $2.9 USDC up front to help the user execute their transaction in 20 seconds, and I'll wait for the Axel network to do it slower, and then the funds come to me, and maybe I take some fee in the process, right?
So in a way, it's kind of like the insurance bond on the chance of the chain reorging.
Yeah.
Exactly. Yeah. So you take a little bit of risk, but you're still going to get your funds if you're kind of helping serve this in like 6 minutes. So it's a very small risk that you take. But from a user perspective, it's like 20-second experience as opposed to kind of 6 minutes experience, so much faster. And so yeah, I do think for a lot of the application use cases, you can actually do very, very like short latencies, which are I think acceptable by many standards.
Axelar as an ecosystem is definitely growing. Now we just saw like Squid Router on the GMP interface. I remember when I was at ETH Denver, one of the winning projects was like it's called Swappy, which was basically tapping into Squid Router to allow you to using some LLM or some AI, allowing you basically to perform some swaps just by performing some intelligible human language kind of requests. I would be very curious to know if there are other cool primitives and cool things that are being built on top of Axelar that you could share with us, and what would be like the best path to get technical support, all kind of support to start building on Axelar as an engineer.
Yeah, I mean, I think a lot of pretty much every use case that you have seen in the crypto space that has like some type of a product market fit right now is kind of a looking to scale, right? And I think kind of interoperability / cross-chain support is the way for these use cases to scale, right? So everything from like decentralized exchanges to kind of borrowing and lending applications, like like Prime is building into NFTs that traditionally been issued like on one chain, but you want to extend them and allow users to kind of trade them, buy them, sell them, and so on and so forth. So if you go to actually like axel.network /ecosystem, you see a lot of kind of ecosystem projects that are building around the stack. I think stable coins is a pretty interesting use case, right? So we announced a partnership with Circle for kind of this primitive called composable USDC, and basically the idea is that as Circle is kind of rolling out their multi-chain strategy, they want to have support for integrating USDC with cross-chain support across multiple dApps, right? So how do you do that? And so we're helping them, with some connectivity there. Yeah, new types of assets I think are being created, right? So there's a lot of talk about like real world assets being issued on blockchains, and the question is like which chain? And I think we're trying to say, well, you can pick your home base chain, but you should be available everywhere, right? And like by connecting with the Axelar stack, you get access to the whole Web3 ecosystem essentially.
Pretty cool.
I would like to go a little bit into the security of bridges. Like first of all, I'd like to give you guys applause for the fact that you guys have been sort of security minded from the beginning. I remember many of the sort of circuit breaker systems that you put in, from withdrawal limits to some other nice things that you guys did, were quite forward thinking at the time. And this is sort of my concern. Like, I 100% believe we need cross-chain bridges, and we will live in a multi-chain world. Personally, again, I work in the ETH ecosystem for scaling vertically and horizontally on L2s, L3, so I quite like the shared sequencer concept for this, but that's not going to be the only future, right? We will have many different chains that we need to bridge in. So I think the most important thing that we need to do and talk about and be very open with in this sort of cross-chain ecosystem are these security issues that are inevitable when it comes to cross-chain, right? So, like, I'm just curious to hear some of your thoughts on how sort of worried you are. I saw on that website there's a long list of tokens that are supported on long list of chains, and there are some. Well, besides user experience problems, like the weakest link problem of maybe a token bridge that would implement themselves on top of your interoperability protocol, where maybe one of those chains gets maliciously attacked or just reorgs, and all of a sudden every other chain might become completely unbacked to the wrap tokens, because that's enough time to steal at least that portion of tokens from another bridge, or at the very least active transports. Like, how do you sort of approach security? Is this something that like keeps you scared at night? Like, you wake up in the middle of the night being like, oh shit, we're gonna get hacked. Like how nervous should we be about this in this ecosystem?
Yeah, no, I think it's one of the most important problems, right, for kind of interoperability protocols. Yes, I worry like, day and night and wake up in the middle of the night thinking about those things. So, but hopefully we do it so, our users and developers don't have to, right? Like, frankly, security is a business of like paranoia, right? And like, you have to be a paranoid to be in it. And if you're not, like, you should do something else, frankly. So yeah, I think it's very hard, I think it's very important to do, but there is a way to do it right. Right. And, first, I think I want to say that I think a lot of the hacks that we saw in the space, like you said, because everybody just rolling out garbage, day and night, like centralized, protocols, like sequences, like, relay, not sequences, but like relayers, right? Or like, oracles, whatever they have, like call it kind of a set up 2 nodes and call it like a decentralized protocol, right? It's a kind of a very, very bad. This is no different than like first waves of centralized exchanges or like DeFi, right, where we saw a lot of bad solutions being rolled out. Many, unfortunately, people lost their funds in the process. This is just the nature of things where you have, strong demand, right, and some of these technologies need a little bit more time to mature. So that's one. From the Axelar perspective, 2 things, I think. So A is, the stack that we have built to be security minded, right, from the day one. So it starts with the right design. So Axelar Network is powered by proof of stake consensus. So it's an open and permissionless like validator set. We implement things like quadratic voting in the network layer to make sure that no too much stake concentration gets too much power. There's all kinds of safety protocols at the network layer itself to like suspend the connection from a faulty network. So if you have a network that all of a sudden like misbehaves, and there's a way to suspend the traffic so it doesn't percolate to all the other networks that's been connected, and that would actually employed used during the Terra collapse as an example, right? So Terra went down, traffic was suspended because people were worried that there'll be infinite amounts of funds printed on other networks, so validators take over, then it was resumed, then it went down, and so on and so forth. So it actually works, right? And like it was used in sort of in practice. So that's starting with the right design. On top of it, security is a function of engineering practices that you have, right? So everything from audits, we've done like over 30 audits to the networks. Like every month there's an audit that's running. There's an active like bug bounty, multi-million-dollar bug bounty that people can go and, if they see vulnerability, they can submit it to us and they get rewarded. We run like unit tests, end-to-end tests. So a lot of just good, solid engineering practices that you have to have to prevent bugs, right? Because bugs are inevitable kind of in any software system, any software stack. And then on top of it is what I call is application layer security add-ons, right? So if you're building a bridge application, well, you probably should have some type of, rate limits, right? And that like, there's no reason that like somebody goes and withdraws, all of the funds from your contract at the same time. It probably belongs to multiple users, right? And so, you need to kind of you need to put that type of a safeguard in the place, and that having like multiple independent
it's left to the application developer, and that always makes me scared because I remember Layer 0 also saying, no, every application can choose its own validator set. It'll be fine if one of them gets hacked. And I went up to one of the guys and I'm like, yeah, but everyone's going to default to the default set. Like programmers
you can't
aren't lazy,
security to the application developers, right? In most cases, like that's the way I think about it, right? Like 90% of security needs to be guaranteed at the protocol layer, right? Because developers don't know how to make security choices, but you still need to give them like 10% that they can sort of customize, right? To kind of have additional like safety in place. You can't say like, okay, by default you customize everything and that's 90% of your security. So like 90% of security really has to come down with good defaults, right? And like we have learned this through the internet, right? When you're building a web page and using HTTPS protocol, right? Like it's complicated protocol, like tens of pages of code and mathematics, right? Like as a developer, you don't know any of it, right? Like you just say, okay, I want to use HTTPS and that's it. Like, okay, maybe you customize like where your certificate is deployed, right? Or how you get like a root of trust or something else behind it, but that's it. So you get like 90% of security through robust stacks that have been built by researchers, cryptographers over the years. Then you customize like the other 10%. And so that's the way that I think about it. Like the network itself has like all kinds of, safety properties. We kind of making it as secure as possible, engineering practices around it. As a developer, you can still customize and you should add like some of these application add-ons if you want to, but they're good to haves. They're not must-haves, right? And so that's how I think about it. That's number one. The second bucket, which I think is actually really, really important, is that the new wave of interchain applications actually can be designed to minimize the risk on the interoperability protocols. As an example, so Squid router protocol that does like cross-chain swaps, it does the cross-chain swaps across DEXs without building any extra liquidity or anything else around it. How does it do that? You start with a native asset, you always end with a native asset, and the risk and the bridge risk in that process is just the ephemeral for the duration of your transfer, right? But there's, you don't need to build like hundreds of billions of dollars of liquidity to perform that application, to just swap like ETH to AvaX on another chain. And so that's how I actually want to think more and more, is that by having like full general message passing across applications, by having full composability, you can think about better designs that have as little risk as possible on the underlying like messaging or protocols that you're using, by passing sort of messages and just composing the applications without kind of a shuffling liquidity back and forth. And so that's something I'm looking forward to working more and more with developers over the next few years, is to think about what is really the right architecture for building applications that are truly interchain native, that has as little risk as possible underneath the hood. And I do think there is a way to do that.
I am curious also, like there's two socioeconomic attack vectors that I'm kind of curious about, like just for the bridge security, which is, first of all, you guys implement quadratic voting. So essentially you take a square root of the voting power that someone has, which is an amazing design because this is delegated proof of stake, right? So they're not just holding their own funds. There might be this sort of network effect that the more someone gets stake, the more people will keep giving them stake. But I am curious about, for this part, I am curious about like, how do you prevent simple attacks on this? Because quadratic voting is, I was going to say only as effective, but really just supercharged, like properly effective, if you can truly prevent SIBLs from using that to their advantage and spinning up 1,000 nodes and then getting outsized voting power from that method.
Yeah, I mean, the reality is because kind of the proof of stake consensus and like the stack that we're running has a limited number of validator slots, right? Like that's the reality, So I think right now it's like 70, maybe we'll extend it to like 100 to 200. So the Sybil attacks become like pretty impractical. Most of the validators that are there, they actually have. I think this is actually a big misconception. A lot of people that think that validators that participate in the networks have something at stake. They don't, right? Like, most of the chains, the validators get stake from someone else and they're participating on someone else's behalf. And if they misbehave, they're losing someone else's funds. So how do we get security? We'll get security by having good, robust sort of validator sets that are diverse, that are decentralized, right? And like they have some reputation sort of at risk, right? And so the validators, that the stake that they get is usually as a result of that, right? And so I think in most kind of a practical instantiations of proof of stake networks, the number of validator slots is sort of bounded by reasonably number, and most of them actually, even if it's bounded, like you end up with stake concentration like in the top 10, no matter what, right? So how do you deal with those kind of a practical, attacks? And I think like quadratic voting in that case, makes sense. You're right. Like if you had an unbounded, validator set, you could spit up, hundreds of nodes and things like that, and maybe nobody knows, who this validator is and like who they are, right? And like they actually managed to accumulate enough stake in that process, then those attacks are theoretically possible. But I think in the practical networks that we have seen, where the validator sets are bounded, where the stake is sort of mostly delegated, it's hard to accumulate significant amounts of stake and things like that. I think the more practical attacks, I think, is what kind of keeps me up at night. And the more practical attacks by saying, okay, you have just a small validator set that you need to kind of compromise to take down like this or that network.
And then the other one that I had on this that's kind of between socioeconomic, kind of just straight attack vector or code issues really, is in most blockchains, let's say there's a bug in a client software, like the ETH validator client. Essentially what they can do is they can just reorg away from that bug. So if someone exploited this bug to print $1 billion of fake tokens, they can just revert the checkpoint and that guy got nothing. One of the dangers with this sort of hub and spoke model for bridges is that if Axelar has a client error or some bug that an exploiter can use, there's not really an easy way to reorg back, because of course you can reorg Axelar network, but that might give them enough time to try to steal funds from some of the other networks. If you have, for example, wrapped assets, or you can do certain cross-chain calls that could exploit or steal money, like, is this something that worries you? Like is there preventative measures for this? I'm just curious, because again, these are the problems that we have in cross-chain, which we need to solve in the longer run as much as possible. And you've mentioned some of those applications like in duration risk, so having an LP bridge instead of a wrapped asset bridge. I'm just curious to hear your thoughts on that.
Yeah, I mean, I think two points. So I think two things. I mean, I don't think reverting a chain, right, if there's a bug, is necessarily like a good solution, right? Like we've done it a couple of times on Ethereum, and maybe that's okay, but it should not be like it should not be the way we think about security, right? It should not be, okay, like if there's a bug, that's okay, we're just going to revert the whole chain and like fork it. I think it's okay.
But not necessarily even a hard revert. Sometimes just a reorg, like an automatic reorg that happens. In that case, I was talking more about proper revert, but
yeah, I mean, okay, if it's automatic rewards, okay, Axel itself, it has like instant finality, right? So it doesn't have like rewards or anything like that. So whatever is finalized, it's sort of finalized by its security model, the consensus, in the same way as you have, kind of on Avalanche, right? Or some of the other chains that have instant finality as opposed to probabilistic finality, right? So that's one thing. I think the second thing, though, again, like going back to these interchain native designs, right? I do think at the application layer, you could have something that deals with problems in your application code, right? So as an example, if you deploy your contracts, if something gets sort of executed, like maybe you have some type of like a delay, circuit breaker, reorg, kind of rewrite state mechanism in your application code, right? So I don't think those are the things that necessarily have to go like on the chain itself, but then at the application layer, you can say, okay, I'm relying on these messages. Maybe there is like a case where, I get to kind of rewrite in my own history, right? If certain logic like on my application kind of misbehaves, and then you can pull those triggers. So yeah, I mean, we haven't seen too much, I guess, ask from developers for these types of kind of reorg/rewrites of the history, but we have seen developers asking us for what additional kind of a security methods you can put in to put like, circuit breakers on their application code. It's not even necessarily that it's because it's interchain or chain agnostic. Like you have bugs, right? And like DeFi, we have seen bugs all the time, like from compounds, the Uniswaps of the world. So I think there's just going to be a larger and larger space of kind of application level security policies, right, that you can instantiate like very easily, that makes it more robust, and like that would include sort of mitigation across cross-chain failures, right, or mitigation against like sequencer failures or things like that.
I think that kind of wraps up this episode. Sergey, Daniel, it's been a pleasure to have you on the podcast, and yeah, as usual, you can find all the relevant links in the description if you want to engage with Sergey or Axelar. I'll make sure that everything is over there. And yeah, if you enjoyed this episode, feel free to subscribe, and I'll see you very soon.
Awesome. Thanks for having us.